Imagine a world where invisible machines are fighting diseases, cleaning the environment and making our lives better. Welcome to the realm of nanotechnology, a frontier of science that's as mind-boggling as it is promising. With a scale so minuscule it's nearly incomprehensible, the power of nanotechnology lies in its size, or rather its lack thereof. Picture this: a nanometer, the standard unit of measurement in this field, is 1/1,000,000th of a meter. That's so small that it would take about 100,000 atoms lined up side by side to even span a single nanometer. This small scale allows us to manipulate and control individual atoms and molecules, opening up a world of infinite possibilities. From medicine to environmental science, the potential applications of nanotechnology are as vast as the universe itself. Invisibility might seem like a superpower, but in the world of nanotechnology, it's just another day at the office. The journey of nanotechnology began in 1959, with a famous lecture by physicist Richard Feynman. Or so the tale goes. Feynman, a man known for his wit as much as his scientific prowess, envisioned a world where we could manipulate individual atoms, crafting materials and machines on an unimaginably small scale. This concept, the idea of controlling the building blocks of matter itself, was the birth of nanotechnology. Yet, Feynman's vision wasn't immediately realized. After all, to manipulate atoms, one must first be able to see them. It wasn't until the 1980s that this became possible with the development of scanning tunneling microscopy. This revolutionary tool allowed scientists to visualize individual atoms for the first time, bringing us one step closer to Feynman's dream. But seeing atoms was only the first step. The real challenge was to manipulate them, to mold them to our will, to make Feynman's vision a reality. This monumental task was first accomplished in 1990. Scientists meticulously positioned 35 xenon atoms to spell out the initials of their laboratory, IBM. It was a small step, but a giant leap for nanotechnology. For the first time, humans had manipulated atoms, proving Feynman's dream wasn't just a dream, but a tangible, achievable reality. These early achievements marked the birth of a new science. They laid the groundwork for the development of nanomaterials, nanomachines, and a host of other nano-sized wonders. Each breakthrough brought us closer to a world where we can control the very fabric of matter, where we can create materials with properties tailored to our needs, where we can build machines smaller than the eye can see. From a vision to reality, nanotechnology has come a long way since Feynman's lecture. It's more than a new science. It's a new way of looking at the world, a new way of understanding the universe, and a new way of shaping our future. And we're just getting started. The rise of nanotechnology has been nothing short of a revolution. As we delve deeper into this fascinating world, let's take a moment to appreciate the multitude of ways in which nanotechnology has been transforming various fields. In the realm of medicine, nanotechnology has been a game-changer. Nanoparticles have been employed as precise drug delivery systems, targeting specific cells and tissues, thereby minimizing side effects and maximizing therapeutic impact. Nanotechnology has ushered in a new era of diagnostic tools, allowing for early detection and management of diseases. Turning our attention to electronics, nanotechnology has been instrumental in making our devices smaller, faster, and more energy efficient. From the nanoscale transistors that power our smartphones to the nanowires used in next-generation displays, nanotechnology has been at the heart of many electronic breakthroughs. In the energy sector, nanotechnology has been driving innovations in both generation and storage. Nanoscale materials have been used to enhance the efficiency of solar panels, creating a more sustainable energy source. In energy storage, researchers are developing nanomaterials that can store more energy in less space, which could potentially revolutionize electric vehicles and renewable energy systems. The realm of material science has also seen profound transformations due to nanotechnology. Nanocomposites, made up of nanoscale particles or fibers, exhibit superior mechanical, thermal, and electrical properties. These materials have found applications in everything from aircraft and automobiles to sports equipment and protective gear. So you see, nanotechnology may be small, but its impact is vast and far-reaching. It's not just about making things smaller, it's about making things better. It's about enhancing performance, improving efficiency, and pushing the boundaries of what's possible. Despite its size, nanotechnology's impact is immense and life-changing. The rise of nano is indeed a revolution, not just in the scientific community, but in every aspect of our lives. In the next segment, we will delve into the challenges of scaling up nanotechnology and how scientists are overcoming these hurdles to unlock its full potential. Scaling up nanotechnology is like trying to build a skyscraper with tweezers and a microscope. This vivid imagery encapsulates the challenges we face when we try to take the incredible power of nanotechnology and magnify it to a larger, more practical scale. The first hurdle we encounter is mass production. In a laboratory, creating a few nanoparticles is a manageable task. However, when we aim to produce these on a larger scale, the process becomes exponentially more complex. Imagine trying to construct billions of intricate nanostructures, each no larger than a speck of dust. It's a gargantuan task that requires both precision and speed. Reliability is our next challenge. Nanoparticles are not always consistent in their behavior. They can act unpredictably due to their size and the quantum effects at play. This unpredictability makes it difficult to ensure a consistent outcome when we scale up nanotechnology. It's like attempting to bake a cake with ingredients that change their flavor at random. You never know quite what you're going to get. Safety is another significant concern. While nanoparticles have amazing potential, they can also pose risks. They're so small that they can penetrate the skin or even the blood-brain barrier. We need to ensure that any large-scale application of nanotechnology is safe for humans and the environment. But despite these challenges, scientists are not deterred. They're researching innovative ways to overcome these hurdles. For instance, they are developing new manufacturing techniques to mass-produce nanoparticles more efficiently. They're also studying the behavior of nanoparticles to understand their unpredictability better. And they're conducting rigorous safety tests to ensure that nanotechnology can be used safely on a large scale. The road to scaling up nanotechnology is fraught with challenges. It is a journey full of obstacles and uncertainties. Yet, it is also a journey filled with possibilities and immense potential. The challenges are significant, but so are the rewards. Scaling up nanotechnology is not easy, but it's not impossible either. And with the tenacious spirit of scientific inquiry, we continue to push the boundaries of what is possible. What if we could create a material that combines the best properties of all known materials? This is not just a hypothetical question, but a pursuit that scientists are actively engaged in. Imagine a world where materials are not bound by their inherent properties. A world where we can cherry-pick the best of all materials and weave them together at a nanoscale. This is the promise of a new conceptual nanomaterial currently being developed. When we think about materials, we often categorize them based on their properties. Steel is strong but heavy, plastics are light but not durable. But what if we could have the strength of steel, the lightness of plastic, and the conductivity of copper all in one material? Scientists are exploring ways to combine these properties using nanotechnology. By manipulating matter at a scale smaller than 1/1,000,000th of a meter, they are creating materials that could revolutionize industries and change our lives in profound ways. For instance, we could have airplanes that are as light as a feather, but as strong as steel, or electronic devices that are incredibly robust and efficient. The potential applications of this new nanomaterial are staggering. It could revolutionize industries from aerospace to electronics, from healthcare to environmental conservation. We could see the creation of super-efficient solar cells, ultralight and durable vehicles, and medical devices that can target diseases at the cellular level. But it's not just about creating new gadgets or boosting economic productivity. This nanomaterial could also have significant environmental benefits. For example, lighter vehicles would consume less fuel, reducing carbon emissions. More efficient electronics could reduce our energy consumption, and in healthcare, targeted treatments could minimize side effects and improve patient outcomes. As we look to the future, the possibilities are only limited by our imagination. As we continue to explore and understand the nanoscale world, we are unlocking new potentials that will shape our future. The future of nanotechnology is exciting and full of possibilities. The journey is just beginning, and we can't wait to see where it takes us. So, we've taken a journey from the inception of nanotechnology to the challenges of scaling up and the potential of new nanomaterials. We started with the invisible power of the nano world, where we explored the birth of this new science. We saw how it has grown, becoming an integral part of our lives, from electronics to medicine. We also looked at the hurdles we face in scaling up this technology, the complexities that arise when we try to increase the size of these tiny wonders. But what's truly exciting is the future that awaits. With the development of new conceptual nanomaterials, the potential for this technology is enormous. We're talking about revolutionizing industries, solving some of our greatest challenges, and opening up a world of possibilities we can't even imagine yet. Nanotechnology may be small in size, but it's big on potential. The future is nano. Please subscribe, like, comment, and share my YouTube channel if you are interested to see more videos like these. Thanks for watching.